Amazing how that works. Technology, man. All right. So, the agenda. What's up, brah? All right. So, the agenda is we are going to build a smart contract that has a data store that is an array. Then we're going to build a custom data type in a struct. And we're going to store a bunch of those structs in that array. Then we're going to build a UI in React that can query that array and display all the items in it, right?
Yeah.
And it's going to be super simple, but it's going to do the full Monty of building a smart contract that stores state, storing state in it, and then building a UI to view it. From scratch, can we do it, Will?
Yeah, we can do it.
Okay. Speak louder.
We will do it.
All right, cool. Let's do it.
All
right. First things first is we need to create a smart contract that has an array and some structs. So the way that we're going to do this is with Truffle, right? That's the simplest way to do it.
Yeah, or we can use Solidity, online compiler, real-time compiler, either way.
Huh, all right. Okay, well, I'm down to use the Solidity compiler then. I think that would probably be pretty easy. Will that give you the contract address on the test RPC?
No, it won't. So if we wanted to deploy it...
We're going to put it in the test RPC.
Yeah, let's use Truffle.
All right, so we're going to make a new directory called... What do we want to call this app? People Viewer? I don't know.
People List.
People List. Then I'm going to cd into it, and I'm going to run truffle init.
Yes.
I should also start the test RPC in this, right?
Yeah.
All right, test RPC started. Truffle init. So I have all these files. Let's open them in Atom. It's going to take its time because my laptop is running about like 50 programs right now to try and do this stream. But anyway, here, this is connected to test RPC, and we're going to make a new contract called people, right? Does that work?
Yeah.
Okay, so how do we do this? Contract people, like that?
Yeah.
Just like that?
Yes.
And it's going to need to have, it's going to need to define a struct called person, and then it's going to need to have an array that it stores the state in of all the people in our system, right?
Yeah.
All right, so how do we go about doing that?
All right. We will start by defining our struct person.
And this is outside the context of any like function. You just put it in the contract, the struct.
Yeah.
Okay.
Yeah. So
cool.
yeah. And what do we want our person to have? We'll have
first name.
Okay.
Last name.
Last name.
And age, which is a number, maybe?
Yeah. Anything else?
No, I think that's cool. 2 strings and a number. Pretty simple.
All right.
And then we need to have some sort of array that is the state of all the people in our system.
Right. So we will create person.
Whoa.
People.
Oh, so that's defining an array that will have the person structs inside of it.
Correct.
Gotcha. Fancy. That's already the fanciest Solidity I've ever done. Okay, cool. So then how do we put a person into it, and then how can we get a list of all the people that are inside of it?
So first we'll create a function that adds a person to the list. We'll call that...
All right, gotcha.
Function, there we go. Add person. Add person. And we'll put returns. We'll just skip this. It doesn't need to return anything for now.
So normally you were saying it would return a Boolean like true to be like it added the person.
Right.
I might as well do it.
Okay.
Let's just do good practices here.
This is useful. So this returning a Boolean like this is useful if you're trying to call this function, add person, from a different contract.
Oh, gotcha. So you can like validate that it succeeded.
Correct. So, and then we'll put a string first name.
Gotcha.
And then, all right.
Cool. And how would this transact that struct? Because I've never worked with the structs before, so I'm not sure exactly how that works. Like, how would you create that and store it in?
So what we need to do is we're going to create a new struct called a new person in memory. And we'll call this.
So what is that memory thing that you just did?
So there is so the Ethereum virtual machine has a call stack, and it also has memory where it can store state variables. And honestly, I'm not entirely sure why you would create a struct in memory before adding it to an array, but
That's what you do?
that's what I do.
All right.
Yeah, all right.
So this is saying you're like basically carving out some memory for a person. You're like, I'm going to make a new struct, and now we're just going to set the variables to it, and then we'll just put it in that array.
Correct.
Okay, cool. So let's see how that would go down.
So new person dot name.
Oh, this looks like JavaScript now.
We can put Jordan.
Well, it would be the first name, right? It would just be whatever's passed into the function.
Yeah, dude.
Yeah, I gotcha.
Needs more coffee.
Seriously.
New person. Last name.
This is cool. I can already see why this would be tremendously useful to be able to just make your own ad hoc data types. I'm sure I would use that for everything, basically.
Yeah, it's. I mean, there are a bunch of use cases. I mean, object-oriented programming is really popular for a reason. There's no reason why we shouldn't, take those same concepts and use them in our smart contracts.
Sure. I mean, that could be a long debate, but we'll let that one slide. Okay, cool.
Yeah.
All right, so people.push. And .push, does that transacts? That's like whenever you people.push, that's changing state.
That is adding an element to the array.
And once you don't like, there's no concept of like saving it. It's just once it's added to the array, that's gonna save into the blockchain.
Yeah. So I mean, that is the piece of this function that is changing state.
Gotcha.
So okay, I see. This is actually useful. So you can create a constant function that does not change state, and you can create like a person object in memory.
Right.
And
that doesn't change state.
Correct. Yeah.
But it's once you push it into that state variable, there's no going back. That now costs gas, it changes state, everything like that, right?
Correct.
And this would have cost gas anyway, right? Yeah.
Wait, cost gas anyway.
Well, I guess this wouldn't have cost gas. Well, I mean doing the person memory new person. Like when you do that,
that's free.
That's free.
Yeah.
Okay.
And we'll see that when we're creating our getters.
Okay, cool. All right, so this can add a person, and then I guess the next question is we want to be able to just then list out every person in the variable people.
Yes.
So that's another thing I've never gotten to, which is like how do you loop through something, kind of. Like I have no idea how to do that.
Right. So let's do that now. What we're going to do now is we're going to create our accessor, our getter, that's going to pull, basically
all the people.
Pull the people from that array and feed it.
Ooh, are we going to need to do a loop?
I think we are, yeah.
All right, this will be fun.
Get people. All right, this is a constant function. It's not changing state. Returns. So in Solidity, you can't. Your functions cannot return
a struct.
A struct. Yeah.
Right, they can't return a struct.
So what we need to do
is
we need to basically return an array of strings and an array of age for the first name and last name and an array of ages.
So the way that you would do something like this is you would make a separate array for each attribute and just return. So you're going to have an array of arrays, like a table, basically.
Yeah.
Okay. That's interesting.
And actually, so there's an issue with this. So there's an issue with this. So strings can be any length, and creating an array of strings could be an issue if you have strings of different length. So this is not normally an issue with some programming languages, but with Solidity it is. So what we have to do is we have to change our strings, our first name and last name state variables, to
A fixed length.
a fixed length.
And they pad it with like spaces or something.
Correct. So
Whew.
we're going to change it to hexadecimal. Okay. Now, so the reason why we're doing this is it ensures that we can create an array of these names without causing any issues with the Solidity.
What do you mean by
compiler.
you're gonna change it to hexadecimal?
Well, we're gonna store them as just bytes of data. So 32 bytes.
Oh. Well, the function can take a string though, right?
It can, yeah.
And so like this add person could do the conversion for us.
I think it can.
Yeah, that's probably the better way to do it, I think.
Okay. We'll
Keep our APIs sane. That actually, if I could have a minute to rant at Ethereum, that does annoy me that like there's all these functions and these libraries that take byte arrays. That's a terrible UX. Take strings and convert things on your own. Those should be library functions. Like when I'm trying to like create a public key and like turn that into a wallet, or like when I take a private key and want to convert that into a public, like all their like implementation functions take byte arrays, and it's so obnoxious to deal with. They should just take strings.
Yeah.
All right, sorry. You can keep going.
Still early days.
Yeah, still the early days.
Yeah, I mean, there's definitely some quirks with Solidity that need to be worked out. Yeah, one of those quirks is that if you want to create an array that contains basically what is a string, we have to cut it off, or we have not cut it off.
You're converted into bytes.
Yeah,
okay, got it.
All right, we have our getPeople function, and so there's multiple ways we can do this. We can either do a for loop, and it'll feed all of our structures, and
sure.
We can just feed all of that out.
The for loop seems easy. Is there like a reason you wouldn't do that because it's like computationally expensive or something?
No. If you're creating a function that changes state on the blockchain, then you do need to be very careful about looping functions, because it's possible if you're looping over say an array and that array gets too long, then you can run out of gas.
Gotcha. But if you're just returning a constant, you can loop all you want.
I believe so, yeah.
Okay.
It doesn't require any gas.
Cool.
Yeah. It's
Solar
debatable
power.
whether this is...
Solar power, baby.
Yeah. There might, I wouldn't claim this is like a best practice or anything, but we're just going to do it this way for now.
Okay, cool.
Let's see. People.length. So this is like JavaScript.
Yep. Yep.
All right. So we're going to create a
3 variables.
person.
Well, there's going to be, I guess before the for loop, we need to make the output things, right? We need to make the first name array, the last names, and the ages.
Yeah. Why don't we do that now?
Yeah.
All right. So we'll create an array. Bytes 32.
Right.
We'll call this name.
First names, right?
Yeah.
Perfect. Still makes sense. So that's that's definitely a good thing.
Bytes 32. Last names. Ages.
Okay.
Alright. And then what we're going to do is we're going to loop over the array. We're going to create a new person structure and in memory, and we're going to populate it with the element of the array that we're currently looking at. And then we will feed the properties of that structure that we're currently looking at from memory into this output array, these output arrays.
So what happens if you don't put that memory word? It just doesn't work. So this is like an important concept that I need to like look up, is like what this memory thing does.
Yeah, I wish I knew the answer to that.
Okay. No worries.
But
look up what memory does in Solidity.
so I know that one of the issues with the Ethereum virtual machine is that, the call stack is it's not very deep. So you can have 16 variables in memory at any one, or not in memory, but 16 sort of like variables on the stack at any one time. And if
16?
Yeah,
that's not a lot.
Yeah, it's very
Oh man. All right,
and we'll say person is equal to people.
Yep.
All right, and now we're going to say.
So we're gonna push onto these arrays like bytes 32 dot push current person, like that kind of thing. Yeah.
Right.
First name.
Push current person.
Yep.
All right, you can type faster than I can.
Okay, but these are still, we're pushing strings though onto that bytes array. Does it automatically? Oh no, it's not. It's bytes 32.
Yeah, we're feeding strings into our add person function, and then those strings are just.
So this function's good. We just need to convert here the first name and last name into that bytes 32.
Right.
So how do you do that?
So I think that actually is taken care of automatically. I mean, I could be wrong, but so I've worked with this before, and it seems like it just kind of happens. Another way you can do it is
so if you just set the data type bytes 32, it can convert a string into bytes 32.
It will implicitly do that, is my understanding. Another thing we could do, yeah, it's probably really bad. I would say it's better.
Yeah, I'm not to actually pass the bytes in.
I would say it's better to do this.
Well, all right. This is an example. This isn't the interface to a function I would actually ship. Just clarifying that.
No, we just threw this together like 5 minutes ago. So
okay. All right, so we're going to actually pass the bytes 32 in. All right, that's probably saner. All right, cool. So that's it, right? Like now we can deploy this, add a couple people, call the get people, and then I will walk you through building the JavaScript UI that can actually query against it.
Yeah, let's see if we get any Solidity exceptions. It's highly
So now we're going to turn first name. So what is this thing that you're doing, this return parentheses? Is that how you define an array? Like what is this actually, this return parentheses thing?
So this is it's called a tuple, I believe, and this is a way that you can return multiple
values. Okay,
multiple
cool.
outputs from a single function.
That makes sense.
Right.
So it's it's the same thing as an array basically.
Yeah.
Okay. Cool. All right. So, should we try to compile this?
Yeah, let's try.
Well, we have to do migrations, deploy, and instead of Metacoin, we're going to change this to people, right?
Yeah.
So other than that, we should now, in this people list project, do truffle compile.
Yeah.
Odds on this working? I'd say pretty good. 75%. 3 out of 4.
We'll see. Oh, yeah. Get wrecked, mate.
What, you messed something up?
Wait, it'll only do one iteration.
What did he say? It will only do one iteration.
Oh, yes. We need
to because you put the return here.
Out of the for loop.
Woo! Thanks, Grant.
Wow, good call.
Yeah, really clutch. Yeah, that was very solid. It didn't compile. Let's try that again. Maybe I was like messing with it as it did that.
Okay, it looks like our output arrays might also have to be initialized in memory.
All right, uninitialized storage pointer.
Yeah.
Pointers, man, that those are normally fun. I'm just kidding.
Yeah.
So what do we need to do here?
We're gonna put this back in. New int length is equal to people dot length. All right. Yeah. This is a really weird way of. Bytes 32 memory. First names equal to new.
Holy.
To All right, and we just want to do this.
Woo! Woo, lad. Yeah, that's fun.
Yeah, it is. Hey, can you?
Here, I gotcha. So, last names, and then this is... Wait, but this is byte... Are you sure this shouldn't be an array like this? It looks like this?
It should be.
It should be, right?
An array, yeah.
Okay, and then this is going to be uint array.
Yeah, and then
Last names, ages. Okay, but we think this should work.
And we need our uint array to be uint.
I was a little optimistic with the 75% chance of it compiling. Should have, Hey, it worked. Achievement unlocked. You thought wrong, Troll Toll. Okay.
Wow. I
I have no idea.
hindsight, that's so obvious.
I have no idea. But okay. Let's see this work first before we get our hopes up too much. So, that is written to test RPC. Oh no, we have to truffle migrate, right?
Yeah.
Will it compile? Yes. Will it migrate? To be determined. Yes. All right. I think we're making progress here.
Yeah, I think we are too.
Truffle console. Okay, so we have... What's so funny? It's going to work. People.deployed. It's a thing.
All right.
It's a thing. And it has an ABI, and it has an address. That's good.
Yeah,
that's what we need.
Progress.
That's all that we need.
Yeah.
So now, let's put some people in it, and let's query it from our console, and then we'll actually do this with the Web3 library in JavaScript in a React app so we can actually see the UI for it, right?
Sounds good.
All right, great. So how do we put a person in this thing?
Wow. I'm amazed we made it this far.
No, it's good. How do we put a person in this thing?
All right, so we're going to get our contract, our people.deployed.
Yup.
And we are going to call on the add person function.
Wait, that's not how you do it. Right? Like, can I just call add person from here?
Yeah.
Really?
Yeah, you can.
Oh, wow.
You can either create a new variable, people.
So then what do I do? Call?
So this is not a call because we're changing state. So we're going to input our function parameters. So
yeah, but they're bytes 32.
So you can just put in like a string. It'll work.
What?
Yeah, I know.
All right.
I know.
Jordan, Lee, and I'm 26.
All right.
So you think that's going to work? I don't know. I'm skeptical.
All right. Well, we'll see.
All right. So now we could do call get people, right? Person.deploy.get people.
Yeah.
Like that.
And call. But yeah, you don't need to do and call. All right. So now, so now we have
bytes. That's the byte array. I take it.
Yep.
That's the bytes 32.
We have Jordan Lay, and it's in hexadecimal.
Oh, but that's just my name. It's just in hex.
Yep. So now.
So wait, I'm just curious. Like if I just Google hex converter.
Yeah.
Hex to decimal. It's not. It's like hex to string.
ASCII. And so Web3
I just want to prove it. Oh, sweet. Yeah. Okay. I'm sure Web3 does have it. I just wanted to see it. I wanted the instant gratification. That's so okay. So you basically are always turning your strings into these hex things.
Yeah, we're obviously doing this very formally. Oh wow. Yeah.
Okay. So stop. Okay. So how do I convert this just in Web3? I'm just curious.
So Web3 has a built-in function to ASCII.
Like that.
So capital A, no underscore. Yeah.
Bang. Okay. Cool.
Yeah.
Very, very cool. Okay, so it looks like that worked. So let's add another person. we'll do Will. Are you 26 also?
I'm 27, I think.
You think? Okay.
27.
All right, and then if we did get people and console.logbit. All right, we've got 2 people in 3 separate arrays.
All right.
All right, so now for the fun part. So now we're going to make a new React.js app. All right, and this is the first time you're doing this, so I can walk you through it.
Yeah, I have no idea
This
what's
is,
going on.
there's something, you're very in luck. There's something called Create React App that is the dead simplest way to get started with React.js.
Okay.
Do you know when this came out? Like 3 weeks ago.
Oh, wow.
And if this did not come out 3 weeks ago, you would be screwed. You'd have no chance of figuring this out.
Really?
Yeah, but fortunately, Facebook open source is absolutely amazing, and they just build everything you need exactly when you need it. It's really crazy how that continues to happen with my life. But anyway, July 22nd, this guy named Dan Abramoff makes this thing called Create React App. All you need to do is npm install Create React App, and then just go into a folder and create React App. That's all you need to run. That's literally it. And then you just put the name of the thing. So we're going to call this Ethereum UI. Or let's do people list UI, right?
Wow. That's fantastic.
And we have a React app. I know. Dude, this is so funny. Like, I love this tweet that, like, inspired this. This guy's like, Mark was almost ready to implement his Hello World React app. That's how I feel with Ethereum. It's like, Jordan was almost ready to implement his Hello World dApp. But,
yeah, I mean, basically creating a very simple array, you know.
Yeah. Yeah, but so you just create React app. This is going to generate everything you need. It's just going to take a minute. And then, yeah, we're just going to need to include one library, which is the Web3 library. And from the Web3 library, because our test RPC is running, we can connect to it, and we can run exactly all those functions and just tie them into a UI. And you'll see how that works.
That's awesome.
Yeah, it's going to be dope.
So I don't want to say the Ethereum Foundation because that's not true, but I know some people that are working with Ethereum are fans of Meteor, using Meteor to create applications that can, you know, reflect the state of the blockchain in real time.
Yeah.
So it seems like React's kind of the way to go, at least.
Yeah, I mean, so Meteor, their whole MO is that they're trying to be an integrated backend framework and UI framework, where they have their own basically backend web framework that connects to a database. And then they have their own client-side framework that connects to their backend framework. So their whole thing is they want to try to own the entire channel that goes from entering something into the database to viewing it on the UI. The problem is that it doesn't work. Just basically because, like, and you see this happen a lot with these kind of frameworks that are trying to do so many things, is like they do a lot of things, but there's always a better way to do each individual thing. So like for UIs, for example, React is a much better solution than the UI framework that Meteor has. And I'm actually pretty sure that Meteor is pivoting to basically just do exactly what React's doing.
Really?
Like I remember reading a thread about that on Hacker News. It's like Meteor.js gives up and is just copying React. And then for the backend, I mean, like, one, you could use a backend framework like Rails 5, which has the action cable WebSocket library built into it now, or Phoenix, which has native support for WebSockets, which are both better backend frameworks than Meteor.js is. Or you could use a SaaS product like Firebase, which is a better database than Meteor is. Or, I mean, like, there's just better solutions at each end of the stack. Like, to me, Meteor.js is like what 17-year-olds use at hackathons to just like quickly build an app. It's not like what you would architect a system in.
Interesting.
So that's my take on it, and smart people, I'm sure, will tell me I'm wrong, but whatever. It's my opinion. Well, anyway, right. We have our thing built here, so we call this people list UI. So I'm going to CD into it, and I'm going to CD into it in 2 tabs. Okay, so all you need to do to start the React app once you've made it, right? So all we did was create React app, nothing else. Now I'm just going to do npm start, nothing else, right? That will start your app on port 3000. So I'm going to pin this tab over here. And the reason it's taking so long is because my laptop is running like I said, like 50 different things. Here we go. This is it. We have a live React app, right? And I'm going to open the code here. And Great. So you are new to React. So basically, I'll walk you through the structure super quick. It gives you an index.html. This is the HTML page that's rendering right here. It gives you source app.js, app.css. So this is the CSS, this is the JS, and then index.js and index.css. You don't need to worry about either of these two files. Basically, just your JavaScript is in this file, your CSS is in this file, right? Mm-hmm. Couldn't be simpler.
Yeah.
Okay, so app.js. If we change something, like if I say instead of welcome to React, welcome to a dApp built with React, and I hit save, it's going to auto reload, right? So once I save it, it auto loads welcome to a dApp built with React, right? So part of the Create React app has a watcher that will be watching for file changes and automatically reload, right? So far, so good?
Yeah.
Okay, cool. So we need one library to actually do the Ethereum integration, which is the Web3 library. We don't need anything else. So I'm going to go to my package.json and I'm going to include it. And what is it? npm JS. I'm just going to see what version it is. Like this. Web3 greater than 0.17 alpha. And then I'm going to close the server and npm install. Wait for it to download it. Then we're going to restart the server and we're good to go. So yeah, I'm assuming that Web3 library has a bunch of dependencies and stuff. Doesn't look like it's anything that bad, just crypto, big number. Yeah, that crypto.js library is awesome, by the way. I've used it before. It just has like all the elliptic curve cryptography functions and stuff you need to do for dealing with the blockchain. But okay, cool. So we're back up. We've got a React app running. Cool. Okay, so now what we're going to do is we're going to initialize a new Web3 client, and we're going to tell it to talk to our test RPC, because that's where our contract is deployed.
Right, which is still running right now in the background.
Yep.
Yeah, that's what
so import Web3 from Web3, right?
Okay.
Look like this, and I'm going to call this Ethereum client. And it's just saying new Web3. And I think this probably needs to be like that. New Web3.providers.http provider, and then the URL that our test RPC is running against, right? So we can use that Web3 library to initialize our Ethereum client. And then just let's, on component mount, let's just console.log this. And again, like I said, this will update live. So here we go. We have our Web3 client, our Ethereum client, and it's connected to our test RPC. And just so you know, so I will do like a full screencast intro to React this weekend with Will. It's going to be awesome. But just your quick primer is just to know these functions are basically what are called lifecycle events. So render is the thing that's called every time the app needs to re-render. Component will mount is the thing that's called right before it's mounted onto the screen. So you want to put like any, just like, I'm just console.logging it once this thing is mounted. That's why I put it in that lifecycle hook.
Gotcha.
But you'll see this as we go, I guess. So anyway, so we have our Ethereum client, and let's see now, I wonder if we have access to it here. I don't think we do. But we should be able to run this exact same function here and get our Ethereum client in our console. So let's see how we might query something. We should be able to do exactly what we're doing with the what we do in the Truffle console now, right? Where we do this.f.accounts, for example, and see all the accounts from our Truffle console, right?
Right.
So basically, this Ethereum client that we have in our JavaScript code in our React app is exactly the same as the Web3 object you'd have in your Truffle console. Like, we should be able to do everything. So the only difference is that with the Truffle dev environment, it preloads the deployed contracts and gives you that like people.deployed thing, whereas now we need to actually go and get it ourselves from the ABI and from the address. So that's a little bit more complexity, but we're just gonna try to do this to prove a point right now, right?
Right. So we need to create an instance of our contracts manually.
Right. So let's just hard code it for now, and then we can put this into an input box.
Okay.
So we need to get the ABI for our contract, and we need to get the address of our contract. So I believe if we go to our truffle console, we should be able to get the ABI by just doing people.deploy.abi, right? And I'm just going to JSON.stringify this here, right? And then so we can say var people contract ABI equals this, but we don't want it to actually be the string. We want it to look like that, right? And then we want var people contract address to equal not the JSON stringify, but people.deploy.address.
Right.
Like this, right? Okay, cool. So probably make the font bigger. Probably help someone out. Okay, so
we have our people contract. It's already deployed onto our test blockchain that's running in the background, test RPC.
Yep.
And since we've already deployed it, we're just going to create an instance of this contract that we can then interact with.
So var people contract should equal, and actually we can test this in the console. Maybe that will be a bit easier.
Yeah.
So we'll make our Ethereum client. Let's save our ABI as a variable. And let's save our address as a variable. And how do we get an instance to the contract? I believe you would do Ethereum client dot what?
.eth.contract.
Okay. And passing the ABI.
Right.
Whew. And that makes this thing called a contract factory, which is a manufacturing plant somewhere, right? No, I'm just kidding. No, so I guess this is a constructor function that can create a contract from an address, right? So eth.contract, and then so dot at, and then I'm going to pass in people contract address, and boom, this is the actual contract object. So this is exactly the same thing as going in truffle and doing whatever dot deployed.
Yeah.
Only we're not using truffle, we're just using a real JavaScript app.
Right. Yeah. So
Awesome.
this is the contract that's currently deployed on the blockchain.
Awesome. So now we have access to our contract. We can save this as a variable contract. We'll save this as people contract equals that, right? So now we have people contract. And now we should be able to call a function on this. I should call get people, right? Boom. Arrays on arrays, son. 1, 2, 3.
Yeah,
Yep.
first name, last name.
And then our numbers of 26.
Yeah.
Although it's not actually 26. It's some weird data structure.
Right.
But okay, cool. So that's awesome, by the way. Really cool. So I can then institute people contract like this and say this is equal to what we just did, which is our Ethereum client dot
eth.contract.
dot contracts or contract or
contract, and then input the ABI.
ABI dot at people contract address.
Right.
And these can be dynamically added through input fields. I'm just hard coding it for now. And let's just display a table, right? So we have our people contract here. So I'm going to add a bit of state to this now. So this is just React stuff, which is constructor props. So this dot state. So the way that React works is you store a JavaScript object that represents the state of your component, and then you define a render function which takes that state as an argument and tells the app how to render based on what the state is. And then whenever you change the state, it will automatically re-render in a really performant way to just reflect the new state of the UI based on the new state of this data structure. Super simple concept, maybe walking through with it. So we're going to have something called, let's just make something really simple now that just says we're going to store the arrays. So we'll do this dot state, we'll have something called ages, right? So it'll look like this. So we'll do first names, last names, and ages, right? And then our render function, for example, we can wipe away these guys, wipe away this guy, and just have a div class name equals app content. And we can just put these into pre tags. So pre is just an HTML tag to just display something in like this small font, but you would do something like this dot state dot first names, right? 2, 3. Move the window. What does that mean? Oh, gotcha. Our faces are over the code. Thanks, son. Okay, so first names, last names, and then ages.
Yeah.
And then when we call this, so on component.willMount, we'll just call this, and we'll do people contract dot get people. Does this return a promise or does this return the data? Let's just console log it and see. I'm not actually sure what that returns. So it looks like that returns the data. That's pretty cool. I thought it would have returned a promise. I'm not really sure how it's doing that, but it's pretty neat.
I think it's because we're running the blockchain
locally,
and we're just calling data. We're not trying to send a transaction.
Gotcha. So when you call data, it can give it to you without needing to make the promise to. But it would probably do a promise if you called not the local one, but the actual one.
Right.
Okay.
Yeah. And yeah, if you send a transaction, then it'll take a while for that transaction to be mined in a block. So.
All right, cool. So now we will do people contract dot get people, and we can do, like data, and then this dot set state. First names, data 0, last names, data 1, ages, data 2. Like that?
Yeah.
And we should see them logged, but objects are not valid. If you meant to render a collection of children. So I think it doesn't like this format of data.
We might have to convert our ages from big number objects to numbers. I think we just use the number.
Let's just make these strings and let's just serialize them. Just to see. Yeah, so here we go. So you see this guy? That we actually do have them logged. I just turned these into strings.
Okay.
So instead of arrays, these are just serialized as strings.
Oh, nice.
Yeah, and actually, I'll one-up you. I'm pretty sure we could get them. We could back these into the arrays by doing string.split. Or React not like the extra trying. Yeah, so there we go. So now we actually do have the state stored as arrays.
Wow.
So now we have 3 arrays, and we want to, instead of just using these pre-tags, we would make a table, for example. Table, t-head, oh, I gotta move this up. T-head, t-body, right? This is just classic HTML. tr, th, and we will call this aid, or first name. Last name, and age. And then the t-body, we will have a tr. So we're going to loop through one of these, basically. So I'm not using Lodash. Lodash is a JavaScript library that gives you a ton of utils. So for doing something like looping through an object even, like I would prefer to use Lodash, so I'm going to include that in. Most JavaScript projects will include Lodash. It's just such a useful utility. So yeah, this is kind of like a bread and butter JavaScript function. So this is version 4.15.0. Lodash. Let's add this guy. And then I will npm install and npm start. So that'll come back. But I was going to say, so now we're here, and basically we want to loop through our, so this is just React stuff, but I would set a var equal to table rows or something equals this, and then dot each this dot state dot first names. Well, you need the index because we have kind of 3 arrays. There's some ways we could probably clean up the way that our data structures are stored, but let's just leave it like it is for now.
Mm-hmm.
So I just want to do low dash each with index. I forget how you do this. Yeah, so it looks like function value index. So I think that we should be able to do dot each this dot state dot first names value index, and we'll do table rows dot push, and we'll push it an object that looks like this: first name this dot state dot first names index, last name age.
Mm-hmm.
So last names, ages. So now we're going to have this array of objects, and we can render, well, actually, sorry, I need to render JSX from this. I'm being silly. So I'm going to do, this will be a tr. So I'm going to table rows dot push. Just bear with me for a sec.
Yeah.
Trying to remember the syntax for doing this, but I think we can just push HTML onto it, so it would look like this: tr, and then this would be td, and then this would be this dot state dot first names index. Yeah, and then okay. Yeah, let's see what that does. So now our npm is started, so I need to import the Lodash library. But yeah, so this needs to just be wrapped in curlies, and I think we are good. And I'll walk you through what this does in a sec. I just wanted to get it to work.
Awesome.
So there we go. Now we have a table, right, of, here, I'm going to minimize this for a sec. So now we have a table of the strings and the ages. Let's turn these back into the actual strings. So JavaScript, oh, you said Web3 has a feature for this.
Yeah, to ASCII.
So I could just do
Web3.
Web3.to ASCII,
Mm-hmm.
like this.
Yeah, it might be lowercase Web3.
No, I think it's alright like this. I think that's just the way that I imported it.
Oh, okay. And then, so the age one is fine.
Oh, right. That was silly.
Yeah.
Oh, do you need a new instance? So I could probably do Ethereum client,
Oh.
because that's like the class. Yeah, I believe that would work then. And there we go. So that's an actual table, and I mean, we could make this nicer looking, obviously. This is kind of the ugliest thing I've ever seen in my life. But the idea is that this is being read from an actual contract on our test RPC. This is a UI for certain values on that. All right, and now the next thing that you would do is abstract this ABI and the address into input fields. So you could input any ABI and any address, hit a button, go get the contract and the values, and then output in a table. But you see how that would kind of work, where you would just store the data on the state, and then the rendering logic would automatically render it.
That's awesome.
Yeah, so that's like a super quick way that you could build a UI around that backend.
So
Do you want to actually do it? It wouldn't take that long to just do the input fields if you really wanted to see it.
Oh, sure. Yeah.
All right, might as well.
Oh, yeah, I have another question, actually.
Yeah, go ahead.
Before we get there.
Yeah, go ahead.
So React's really fantastic because if your data changes, then that change in data will be reflected in the user interface.
Yeah, so the big idea of React is that it's a rendering library that makes it easy to build stateful user interfaces. So something that the state of the page is constantly changing, and it makes it really easy to just localize where you're storing the state and define your rendering logic as a function of that state. So in this case, we don't know what the first names, last name, ages are going to be. But based on what they are, we want to render as a function of what they are. In this case, we want to render a table as a function of what the first name, last name, and ages are. So we can we can just define that rendering logic here. It's just saying for each item, push on a table row that looks like this and render this HTML snippet. And then we can go outside in the logic, go get the values from the contract, and then just update the state, and the app will automatically render it.
That's really cool.
Yeah.
So this is really neat. And I think it's really exciting because in some ways you could think of this people contract as it's kind of like a database that anyone from anywhere in the world can access and add their name to that database. So how would you...
Yeah, that's really interesting.
So maybe we can't do it now, but how would you modify this application to update the list if someone, say, on the other side of the planet was to add their name to the...
So you'd want to be able to see it live, is what you're saying?
Yeah.
Well, so as I understand it, the Ethereum protocol has something called events.
Right.
Where when a specific event is triggered in the blockchain, you can actually hook into a listener from the Web3 library. So what I would probably do is just have the same React thing, but have a listener that says if a new person is added or if a person is removed, go get the people, save it in state.
Okay.
So we could just trigger that function, and it will just go get the people, save it in state, and the app would automatically reflect. So it's really about how that listener function. Because something like Meteor, like that's great if you have the database, but we don't have the database. The database is on the blockchain.
Right.
So there's no point in trying to try and have the database touch your UI. It's better to just query for the initial state and then just have listeners for each event when that changes.
Right. And so instead of say like a new person event fires, we didn't implement the new person event in our smart contract.
Right. I don't even know how to do an event. I've never done that before.
We could do that. It's very easy.
Yeah.
But let's say that a new person event fired. Instead of looking at the first name, last name, and age of the person, if that's contained in the event, rather than adding that to the list, instead what we would do is we would refresh the entire list.
Right, because that's what's awesome about React, right? Is that you can set the state and not worry about, well, we had this and now we just reset the state, because it will figure out the delta. It'll be like, the new state looks like this. If I tried to render it, I would have 4 table rows. The actual UI on HTML has 3 table rows. The delta is 1 table row. Let me just inject that table row in.
Wow.
That was kind of the breakthrough that they made, is they would be able to run your rendering logic against the new state, see what the outputted HTML looks like, look at the current DOM, and be like, what's the delta here? Let me just inject the delta. And that's really powerful, because you don't need to wipe away the entire DOM and re-render it. You're only rendering the delta, so it's insanely performant.
Wow, that's super cool.
Yeah, React is just, it's great. I mean, it's the single best UI library that's probably ever been made. So it's Facebook runs on it, right? So
right.
they know what they're doing over there.
So that's super exciting I could see that, this is the type of thing that we'll eventually get to, where instead of having a boring like people contract. Instead, you can have smart contracts that have games. So, multiple people interacting with the smart contract in real time.
Sure. Yeah.
And that's all reflected in the user interface. So that's really exciting. Exchanges, for example, is another one where people are placing bids and asks, and
it's cool stuff.
Wow, that's really, really cool.
Yeah, awesome. Well, really cool. And I think that's like iteration 1, but I'm sure we can go through some more iterations going forward and really amp this stuff up. If you want to pair again on doing something like slightly more complex, I think that might be pretty cool with events and with like actual dynamic UI kind of logic.
That would be extremely cool.
Yeah.
I would be very much into that.
All right, cool. All right, thanks for watching.